So now we want to find, with a triple integral, the volume of the solid inside the cone, z equals the square root of x squared plus y squared over the square root of 3, between the planes z equals 1 and z equals 2. So let's look what that looks like in Maple for a second. So it's this cone right here. So there's our cone, and we're cutting into it with two separate planes, right? Z equals 1 and z equals 2. And we want the volume of this space in between those two planes. That's the goal. Okay, so let's draw that. So we have our coordinate axes, and we have our cone. Not drawn well, but there you have it. I got a little wobble on that one. All right, so there's our cone. And we're going to cut into it with two separate planes. So we kind of come into it down here, right? That's z equals 1. And then we're going to cut into it up above. I just need another color here. All right, up here, that's z equals 2. And we're really looking at the volume in between those. Okay, so let's remind ourselves of some things, right? In spherical coordinates, we have some ideas of what some of these objects looked like. So z equals 1. Remember that when you have a plane, a horizontal plane, when it was z equal to a constant, that means rho is equal to the constant times the secant of phi, right? Or if you will, it's that constant divided by the cosine of phi. Either way you want to do it. Okay, so let's remind ourselves. When z equals 1, that means that rho is equal to 1 times the secant of phi. All right, when z equals 2, that means rho is equal to 2 times the secant of phi. All right, good. That's the horizontal planes. Now, what about that cone? Well, remember that when you have a half circular cone, z equals a constant times the square root of x squared plus y squared. That's really the cotangent of phi is equal to that constant. And that's how you can figure out what phi is. All right, so let's look at our cone. Now, at first, it doesn't seem like it's in that same form, but it is. So remember that this is really z equals 1 over the square root of 3 times the square root of x squared plus y squared. So our constant, c, is right there. Okay, so then that means that the cotangent of phi is equal to that constant, 1 over the square root of 3. And that means that phi is equal to the arc cotangent of 1 over the square root of 3. Now, using your unit circle knowledge, there's an angle in the first quadrant that would have the cotangent, right, which is cosine over sine, equal to 1/2 for the cosine and square root of 3 over 2 for the sine, and that would work out. And that is pi over 3. We love our unit circle. It's very, very helpful. Okay, so now we're ready to set it up. So the volume, remember, is the triple integral over the solid of 1 dV. So let's set up that triple integral of 1, and then we know it's going to be rho squared sine of phi d rho d phi d theta. Okay, so theta, as per usual, is really easy to figure out because we're doing the whole thing. We're going all the way around. So theta is 0 and 2 pi. 0, 2 pi. No problems. All right, what about rho? Rho is also usually pretty easy to figure out. So if you imagine a spoke coming out from here, right, it would hit the bottom plane first and then hit the top plane, right? It would hit the green one and then the maroon one. So we know what those values are. that is rho equals 1 secant of phi, or just secant of phi, if you will, and 2 secant of phi. We already figured those values out, right? I crisscrossed them, but that's what they are. All right, so we know where we're hitting, right? Those are a little bit tricky, but we figured it out. And then now phi. Phi is going to start straight up at the z-axis, and it's going to tilt over. So we go from here, which is phi equals 0, out to this edge of the cone. But we already figured out where that cone was. It's pi over 3. Right? See at the right. Okay, so then we know we're going from 0 to pi over 3. All right, so let me see if I can get all of that on screen together. Whoop, there you go. Okay, so now we just have to start integrating. Now you'll notice, yet again, there is no theta in this entire integral, right? There's no theta anywhere. So that means that we can cross off one of the integrals and turn it into 2 pi out in front, yet again. We do it a lot. Okay, so then for where I have to integrate this, I have to go rho first. I have to, because these have phi's in them. So I can't do phi first because I would be missing this. So I have to go with respect to rho, which is okay. I mean, rho is not particularly difficult. All right, so phi is going from 0 to pi over 3. And then I'm going to integrate this with respect to rho. So I'm just going to write the sign of phi here. You can kind of write it in the front or the back. It doesn't really matter. And then it's going to be rho cubed, and I'm actually going to think ahead and bring the third out because it's not really relevant, right? It's 1/3 rho cubed. And then I'm going to take that from, secant of phi to 2 secant of phi, right there. And then I still have my d phi right here, out in the back. Okay, so then that's really 2 pi over 3, integral from 0 to pi over 3, sine of phi, and then we're going to put this in. 2 cubed would be 8. So it'll be 8 secant cubed of phi minus secant cubed of phi. And those are like terms. So we could make our lives a little bit easier by saying that is 2 pi over 3 integral from 0 to pi over 3. It doesn't really matter because we're going to stick this in maple anyway, but that's okay. So this is 7, right? So sine of phi, I'm going to put 7 out in front, and secant cubed of phi, d phi. And we're just going to make maple do that. We're not going to do that. So that is a maple integration. So let's go see it. And lo and behold, it becomes 7 pi. Right? That's what it is. All right, so 7 pi, that's the answer, or 21.99. So 7 pi, or 21.99. Now, I didn't give it units, but I should have. So let's pretend this is in meters or something. So if x, y, z are in meters, when we found this, we're finding the volume. So that would mean meters cubed for these, for your unit. And we're all set.